Is it audible? My sound is clear to you?
Yeah.
Okay. This is just a summary of the reactions of chromium. That's the last week we did. So, example, if you have dichromate, because and here these are the oxidation number of the chromium in the compounds, because chromium can be +6, can be +3, or it can be +2. So if you have chromium or dichromate ion in which the chromium oxidation number is +6, if you add an alkaline medium, it will form chromate ion. Oxidation number does not change, only the existence in an alkaline medium you will have CrO4 more, and in acidic medium you will have orange solution. So if we have a chromium ion +6 sign, in acidic solution it will appear to be orange, and in alkaline solution it will appear to be yellow. If we add zinc, zinc is a good reducing agent in the presence of hydrochloric acid, or if we add iron 2 ion in the presence of hydrochloric acid. So this chromium +6 will change into chromium 3, and it will form a complex with water. So oxidation number will change and the compound nature will also change. It will form CrH2O in a bracket 6 and +3 is there. If we add excess of ammonia, it depends on, like, this is a test. If we add a limited amount of sodium hydroxide or ammonia, sodium hydroxide, OH ion or ammonia, they are proton acceptor. So what they will do, they will accept proton. So out of 6 water molecule, 3 of the water molecule will gain proton. So because if H2O is there, there are 6 water molecule. Out of 6, how many will lose depending on the chromium oxidation number? Chromium oxidation number is +3. So 3 of them will lose proton due to the hydroxide ion or ammonia, because both are proton acceptor, both will accept proton. So what it will form? It will form CrH2O 3 water, and out of 6, if the 3 water molecule which lost the hydrogen, so they will turn into OH. So they will have 3 OH ions, 3 water molecule, and chromium +3. And because chromium is +3, water is a neutral ligand, and hydroxide is -1, 3 hydroxide will be -3. So overall this compound will be solid because it does not have any charge. And if we add an excess, so more protons are lost, because chromium hydroxide, why it lost more proton? It shows that the chromium hydroxide is acidic in nature, because acid tend to lose proton. So first what happened, there were 6 water molecules. Out of 6 water molecules, it lost 3, and it will turn chromium hydroxide. So CrOH3, and there are 3 water molecules are also attached, so 3H2O will be there. Then what happens if you add more or excess of sodium hydroxide? Then more protons are being lost, so means this chromium hydroxide is acting like an acid. So first the complex was acting like an acid, but now the chromium hydroxide is acting like an acid, and it lost all of its all of its proton from the water molecule which are left. So what it will turn? It will turn into CrOH in a bracket 6. Then what will be the charge? 1 hydroxide is -1, 6 hydroxide will be -6, and chromium is +3. So overall it will be -6. Sorry, -3. This will be minus. And appearance, you have to learn, it will form a green solution. So if you remember O levels, you learned, like when we add sodium hydroxide and then we add an excess of sodium hydroxide, sometime it form a precipitate, and sometimes the precipitate will dissolve. So why the precipitate will dissolve in excess? There are 2 reasons. Either there will be a ligand exchange, or either there will be an acid-base reaction again. The first reaction is an acid-base reaction. Why? Because the hydroxide ion or ammonia ion tends to accept proton. But the second reaction is also an example of acid-base reaction, which shows chromium 3 hydroxide is acting like an acid because it is losing more proton, or we can say chromium 3 hydroxide is amphoteric in nature. Why amphoteric? Because it contains hydroxide ion, so it can accept proton. But because it lost proton as well, so means it can act like an acid, it can act like an alkali. So this substance is acting like an amphoteric hydroxide. Then if we add excess of ammonia, then excess of ammonia, the oxidation number does not change. What happened? A ligand exchange occur. All of the 6 water molecules are replaced by 6 ammonia, and the solution will be purple. Same thing if you add zinc and hydrochloric acid in a hydrogen atmosphere, when hydrogen is there, so it will further reduce into lower oxidation number. Chromium 3 will be 2 will be there, which is blue solution. If we add or oxygen is there from the atmosphere, it will return back to chromium 3. Common state is +3, but it can be +2 as well. Is it clear? This is the chromium summary of the chromium compounds.
Yeah.
Okay, copy this. The transition element, it exists as a complex. So what happened? The copper ions are surrounded by 6 water molecules, and the solution will be blue in color. If we add concentrated, means a solution which contain more chloride, such as hydrochloric acid, or a solution which is having higher percentage of chloride ions, so there is a ligand exchange. The water molecules, 6 water molecules, are replaced by 4 chloride, because while less number of chloride, because these chlorides have charge and like charges repel each other. So the molecules which surround the copper ion will be few. That's why the oxidation number of a copper changes, and the solution will appear to be green or yellow in color, because the solution color will change if there's a change in the ligand or if there is change in oxidation number. And if we make it dilute, like if we add too much water, then again it will turn blue in color. So both the reactions, its oxidation number does not change, it's +2, but the only thing what changes is the ligand. Then if we add a sodium hydroxide or aqueous ammonia, so they are proton acceptor, so they will accept proton. Copper, if its copper charge is +2, it will first lose 2 proton. So you can see it will become copper hydroxide, and the precipitate of copper hydroxide, it will form blue precipitate. So this will be blue in color. If we add hydrochloric acid to this, means we provide proton, because acid are proton donor. So this will take the acid or proton and it will again turn blue. Then if we supply the heat energy to this copper hydroxide, so copper hydroxide hydrated or complex, on application of the heat, it will turn into copper oxide plus steam. And copper oxide is black in color, so what we'll observe? We'll observe a black solid, which is copper oxide. Or if we add an excess of ammonia, so the precipitate will dissolve and it will form a deep blue solution. But here the precipitate dissolve is because of a ligand exchange. It is not an acid-base reaction. You can see here, there are 4 water molecules and 2 hydroxide. But when we add excess of ammonia, there are 2 water molecules and 4 ammonia molecules. So the ligand or the number of the ligands change. Total remains 6, but number of water molecules change and hydroxide is also changed. So this precipitate dissolved because of ligand exchange. And previously the chromium, the precipitate were dissolved because of acid amphoteric nature, or again acid-base reaction. And if we have copper 1 iodide, which is white solid, why the copper 1 iodide is white solid? Because the d orbital is complete, that's why it will give a white solid. If we add sulfuric acid, H2SO4, then what it result, it will give copper 2 and as well as it will give copper metal. So orange or a brown solid will form and a blue solution will form. If we add ammonia, excess of aqueous ammonia, then it will form a complex with ammonia and it will again form a colorless solution. Why? Because in copper 1, the d orbital is complete. So this is the summary of the reactions of copper. Is it clear?
Yeah.
Copy this part as well. If the metal oxidation number is +3, then the charge on the complex will be +3. So if we have like MH2O and where it's limited to M can be iron. If it is iron, then it will be green solution. If iron 2 is there basically. If nickel is there, it will be green solution. And if manganese is there, which is +2 in the solution, it will be very light pink. If zinc is there, it will be colorless. If copper is there, it will be blue. And same thing if metal is having oxidation number +3 and it will exist as a complex with 6 water molecule. Chromium is there, ruby, and iron is there, which is violet in color. So iron +3 solutions are violet in color, where iron +2 solutions, when they form an aqua ion, metal aqua ion, so you have to memorize these colors. Then what happened? In solution of chromium 3 often they appear green and iron 3 appear to be yellow brown. Why? Due to the hydrolysis reaction. The ruby and the violet color only seen in solid hydrated salt that contain these complexes. Basically, there is a hydrolysis reaction. When we call hydrolysis, the compound decompose or break due to water molecule, we call hydrolysis. So mainly, if you have a chromium +3 in a solid state, hydrated salt is there in a solid state, what it will appear? It will appear to be and iron 3 is there, so it will appear to be violet. But if they are in the solution, like chromium solutions is there, it will appear to be green. And if iron 3 is there, it will appear to be yellow brown. So what it means, like example, if I have iron 3 sulfate, so Fe3 oxidation number and sulfate -2. So this is iron 3 sulfate. So what will be the appearance of this iron 3 sulfate when it is solid? It will appear to be violet in color. But when we add in water, when we dissolve, iron is separated and sulfate is separated. So what should be the color if iron 3 is there? When water molecules will surround it and make a complex or metal aqua ion. So its color should remain violet. But what happened? It does not remain violet because of hydrolysis reaction. Due to water decompose this, so what it appeared to be yellow or brown due to hydrolysis reaction, the solution. So what is acidity or hydrolysis reaction? Basically what happened, like example, the following happened to the metal ion when the water molecule, and this will lose its one proton. When it will lose its one proton, so there will be 5 water molecule and 1 hydroxide. So this is called hydrolysis reaction, and due to this hydrolysis reaction, the color, what is the actual color of the ion might change because the oxidation number is not changing, but there is a change in the ligand. First all were water molecule, but now one of them is hydroxide and 5 of them are water molecule. Then the acidity of +3 is always greater than acidity of +2. Why? Because the +3, basically what happened, like you have H2O and the charge on the metal is +3. So this +3 will attract more, this hydrogen, because oxygen is partial negative, hydrogen is partial positive. So this hydrogen is attracted more towards the positive ion. As this hydrogen attracted more towards the positive ion, so this water can lose this proton easily to the other substance. That is why when the charge on the metal ion increases, the acidity of a solution or tendency to lose proton of a solution also increases. So it causes greater polarization, more attraction towards the hydrogen of water molecule, that will weaken the OH bond, so proton can be lost easily. Is it clear?
Yeah.
So metal aqua ions, and this equation. And the heading is acidity or hydrolysis reaction. So basically what happened when you add a salt which contain a transition element, it will form an aqueous solution and form a metal aqua ion. And this metal aqua ion, it's also hydrolyzed by water, and it will lose its proton. Either one proton is lost or two proton. No, but the overall charge, because it remain as an ion, so the overall charge will be there on the complex. It will not form precipitate because there is a charge on the complex. First, it's an acid-base reaction or deprotonation or acid-base reaction. Like example, if you add aqueous ammonia, limited amount, or you add sodium hydroxide, you have to learn the color of these precipitate, the final reaction equation, but the color of the precipitate is very important. So what happens if you have a complex of zinc? So two ammonia, they tend to accept proton. So when it will accept proton, it will become ZnH2O, 4 water molecule, and out of 6, 2 of the water molecule lost proton, so they will become OH. So basically it will become zinc hydroxide. And what is the appearance of zinc hydroxide? It is white precipitate. Same way, if we have chromium, we add hydroxide, it will become 3 water molecule lost proton, so it becomes chromium 3 hydroxide and chromium 3 hydroxide. What is the color? It is green precipitate. So this is an acid-base reaction. But when we add an axis, some of the hydroxide dissolve. Why some of the hydroxide dissolve? Because they are amphoteric. Like these hydroxide normally are alkaline, they tend to accept proton, but some of the hydroxide tend to lose protons, such as zinc and chromium. So when we add hydroxide axis, they will lose further more proton and the precipitate will form, and they will form a solution. So the part which you have to copy, is it clear? It's a similar thing which I discussed earlier. Only the color of the precipitate and the equation you can form. How you can form an equation? Forming an equation is not difficult thing. Like if I say iron 3 is there, so complex of iron 3 is there. So what is the charge on the complex? Same number of molecules should add. Like if hydroxide, if I'm reacting with hydroxide, so 3 hydroxide should be there. Because the 3 hydroxide will accept 3 proton, and what it will form? It will form Fe, H2O, 3, and then OH3 will be there. And OH is -1, 3 will be -3, iron is +3. So this overall will be solid. And if iron 3 solid is there, what we'll observe? We'll observe brown PPT or brown precipitates.